All right, so I just share with my students that I'm not the biggest fan of this next thing about with inverses and what's called restrictions. Can everyone say restrictions? Okay, so that's what we got today, and that's why that quiz is that I did. And I think I will throw it on the calendar. Let's go to the internet thing here. No, that's not the internet. And then go to my calendar. But I am gonna. We did a quiz is, and I'll put it in here if you wanted to do it again. Um, Someone came into Compass today. We remember him. He used to be here. Um, but he said, I just really don't know the unit circle stuff. It's just the unit circle I don't know. Well, I said, I can't really help you. At this point, we've been on it for a month. And then we've taken a break from it. What you could do is go to, where was it? I had a quizzes. Here it is. Through Google Classroom, we did that quizzes right there. You could do that forever. I have it all the way till May, I think, open or infinite. You could do it next year. Hey, I miss Mr. Samuelis's voice. Let me play that quizzes where he describes the questions. That'd be nice. All right. But that is, ignore maybe. I told him, you know what? Don't do 1 through whatever. Go to like 11, 12, 13, and then skip to 17 through whatever. And that was all the unit circle. Bang, bang, bang. And then first hour ruined it. But maybe you should go to that Delta math that I had in that Delta math with radian measures. And then it was like quick, what's the sine of pi over 6? What's the cosine of 11 pi over 6? What's the tangent of 7 pi over 4? And then bang, bang. And then Delta math actually teaches. If you got it wrong, you can look at the explanations. But I'm done. You have to know that unit circle, but it's going to come up in the notes. And then the quizzes today, we did one to kind of try to reiterate that. I'll put that in the calendar for anyone else that might want to do it. But here's the thing. And the quiz is built up to this idea. Maybe highlight some things. This maybe works for people that are missing. You could read the notes all day long. My pen has been a jerk. But this is what we're doing today. And it's flat out standalone inverse questions. Okay, so, and I want to write this, and let me move my fat head out of the way here again, but I do like showing that I'm in class, so, sorry if you don't like my face. But here's the idea, and I don't think enough students understand this, not you now, but students of the past. You sine an angle, and the result is a ratio. What do you inverse sine? The reverse. You inverse sine a ratio, and the result is the angle. That's the flat out, straight out information that sets this whole idea up. But there's a bunch of problems. And you read, I'm not reading. Sometimes there's too many words in our notes, but they are good. I just don't think people read much anymore. Is sine a function? Let me ask you that silly question first. Is sine a function? Yes or no? Yes. What test did I just do? Vertical line test. Is sine 1-to-1? Is sine 1-to-1? No, you don't remember that, do you? But look at that horizontal line, and it hits a lot of times. So what do you think the answer is? No. Why it's not 1-to-1 is because they're repeating y values. So, is that what I put there? Not 1-to-1. This creates our conundrum, our problem for mathematicians. So, and then just put repeat y's. I'm kind of in the way here, but that's all right. I guess I am always in the way of the screen. Repeat y's. I'm just going to speak very badly. All right, bad English. Okay, that's why it's not 1-to-1. Mathematicians can't stand that. As a Fatterum act, when they try to find, hey, by the way, when I say inverse, you say switch X and Y. Good. Way to be right on top of it. I still have people in this room that have never answered one of those questions once, and I just see them. I see them right now. I'm not looking at you, but I see it. Not once have they answered one of those group responses. What's 2 plus 2? All right. So anyway, all year long. So enjoyable. Teaching in America. I got to get that in there too. Hate mathematicians non-functions. Very, very bad. So here's what they do. Hey, when I take you said switch X and Y. That was the first thing that I went on my little diatribe. If I switch X and Y in this truthfully, and graph the inverse, this would be the picture. Is that picture a function, yes or no? 3, 2, 1, go. No, I don't think that's me. No, no, it's not. Because it fails the vertical line test. Okay, got it? So, mathematicians hate that, so they restrict the domain. Why would they restrict it from here to here? It's because then this little piece does pass the horizontal line test. Just the little yellow. See, look at this. Pass, pass, pass. If I'm not allowed to go past that and only hit that yellow part, then this is 1-to-1. So the domain of sine is actually all real numbers. But now that restricted domain gives me a 1-to-1 function, and where I get all of my unique, I gotta hide this, all of my unique y values is from this set of x values plugged in. Input, say it. So those are the inputs that create this output, and that's enough. That's all I need to create that output of -1-to-1. I like how I wrote that in that order. All right, I gotta take care of it. What is this now? When was this? And then this is, you didn't sign up, right? So all right, you gotta sign up for Compass. This is getting to be really a problem. Who's gonna do this? I'm in the middle of a. Okay, really becoming a problem. All right, so now, okay, back to this. So when I say inverse, say it one more time. So, wow, okay, all right, taking care. She's really mad at the others that don't answer, so she's trying to really take control. 1, 2, 3, 4. 1, 2, 3, 4. So hey, this is going to be -1-to-1. That's why I had him say switch x and y, because now the x-axis is the y-axis, the y-axis is the x-axis. And what I'm doing is I'm producing the graph of the inverse. Now, I think the AP, we were saying the AP was a little too much on the graphing of inverses and a little less on the evaluation. We're going to reverse it. We're going to talk more, not so much on the graphing part. And then the x-axis is restricted to pi over 2 to negative pi over 2. I should say negative pi over 2 to pi over 2. And by the way, last time I'm covering this, when you write interval notation, if you write 1 comma -1, you're wrong. If you write pi over 2 comma negative pi over 2, you're wrong. I'm still getting people that can't put these in order on a number line. And I do every once in a while reference it. If you did come into Compass to check over tests, which you could see these mistakes, but not many of you do. Some do. So, but just something that I just popped in my head. All right, and then the same thing. I won't ask you to say it, but when I say inverse, you say switch x and y. I could just switch those coordinates. I know you were excited. Sorry. So 0, comma 0. All right, that's I switch x and y. I still get 0, 0. But then this point is pi over, I mean, come on, we should know that. Sorry, I went over that fast, that's pi over 2 there. We're good with our fractions, right? So we get that. So that's pi over 2 comma 1. Now it's 1 comma pi over 2. Got that point for the inverse, right? Right. And then this one is negative pi over 2 comma -1, but now it's -1 comma negative pi over 2. And I tried to do this in class. I think this graph is too stretched out to get a curve. I don't know, because it just doesn't show up as nicely as I'd like it. But pi over 4 gives me root 2 over 2, which is approximately 0.7. So therefore, root 2 over 2, I'm sorry. Pi over 4 comma root 2 over 2 is now root 2 over 2 comma pi over 4. Root 2 over 2 is 0.7, and then this is kind of pi over 4 right there. So it should be more curved than I'm probably making it, but that's the best we can do there. And then notice, this is a function. It passes the vertical line test. If I would have kept going, then it would have been repeated and then not a function. Mathematicians are obsessed with functions. All right, next, let's move on. I felt like I've taken too long on this. Oh, by the way, what's the domain and range? Okay, one more time. When I say inverse, you say. Mrs. Cooper hates that. She likes domain and range exchange. So I will say that she trained me on that. And this is why, because this is actually a better statement. It is a better statement. I'll agree, Mrs. Cooper. All right. All right. So therefore, that's the domain and range, and it's restricted. So here's the key here. The outputs that I have to answer are very specific. This is the big deal today. It's really the only hard thing. Your homework should take 10 minutes or less. Depends on your training on the unit circle, though. All right. And then next, this goes from here to here. I'm just going to get to the brass tacks of it. Doesn't that cover all of those? It's the same thing. Cosine's not one-to-one. I got to restrict the domain. I got to find a piece that covers all the y values. That's the piece. So the domain is all real numbers, but we're going to restrict that domain to just the inputs that create 1 to -1 directly. It's not the same as sine because it's not a same graph. So that's the restriction, and I probably should highlight that. What I colored on the picture, the restricted domain piece that covers the y's that I want. The range is still 1 to -1. Wrong. -1 to 1. I just said I'd mark you wrong for that, and have for those that cannot put those in numeric order. All right, a big problem. All right, and then real quick, we get the idea, I hope. 1, 2, 3, 4. Plus, I'm a little worried about time. I felt like our quizzes, I felt like I added more questions than first hour because it was just an idea when I was driving in. It's like I want to do a quizzes, and then it took me a long time to set up. 1, 2, 3, 4. Wish I would have thought about it yesterday. I had time to make it yesterday, just didn't come into my brain. Same axes, 1 to -1, whereas this is pi over 2. Wrong. 0 to pi, 1, 2, 3, 4. That's what the restriction on the domain was originally, which is now a restriction on the range. My bad, dogs. All right, and then I could take this. This is 0, 1, just to go over this real fast. So now it's 1, 0 right there. This one at the extreme, this is pi comma -1. So this is -1 comma pi way up here. And then, I don't know, let's just do one more and get our curvature. This is at, what is this? This is pi over 2. We've been trained on that. So it's pi over 2 comma 0. So now it's 0 comma pi over 2. And then you get that little curly Q here. Okay, something like that. It's not a line. It's supposed to be curved. It's just not showing up very good on this grid. Okay, 52. You'll see how fast we actually do these questions. What I'm setting up, and I told you this 20 minutes, the why is not important. The what is. And the what is this. I almost didn't write it. The domain is -1 to 1. The what is, when you're answering inverse questions standalone, this is the problem. You can only answer inverse questions under these parameters. That's the what. The why, maybe not as important. I'm just trying to be practical. I like to teach you practicality. Like, what do I really need to know? All right. And then this last one, I think you could agree this is not 1 to 1. And I think you could agree that one piece covers all the range values, right? Okay. So the domain is actually very specific. Let's not cheat you on that one more time. The domain is x such that. This is like the 4th, 5th, 6th time we've written this for the parent function. Domain, you say x can't equal. X can't equal the asymptotes. One of them's at pi over 2. The rest of them are the period away. And then we'll use n today. N-E-Z. Okay, so that is a specific domain issue for all, but we're going to restrict the domain to just those enclosed 2 asymptotes that cover, and I have a mistake. You technically can't plug in -pi over 2 or pi over 2 because you get undefined output values. So you're supposed to put parentheses around that. And then the range actually is all real numbers. So what's the domain of our new graph even before I graph it? All real numbers. What's the range of our new graph? That's a parenthesis, the restriction. And then I'll synthesize. The synthesize and the last part of the homework is, or like notes that mirror the homework, are easy. But real quick, let's draw this. So I basically go forever. So I don't have, but I'll just use four. I'll go four of these five. Um, I don't know. I'll just leave it at that because really it's the range here. One, two, oops, sorry. One, two, three, four. Go up two and down two. This is pi over two for a y value. Remember domain and range exchange, and negative pi over two. And what ends up happening, maybe I'll go green. These are now the asymptotes for the inverse tangent function. The inverse of a horizontal, I'm sorry, the inverse of a vertical line is a horizontal line. That is true. And then, real quick on this, maybe I'll note it with you guys. When I say inverse, you say, oh man. So this is approximately close to pi over 2, comma, close to 3. Switch that. 1, 2, 3, close to 3, close to pi over 2, right? You know, that's kind of good. And then switching 0, 0 is 0, 0. And then this is close to negative pi over 2, comma, close to negative 3. Switch that, close to negative 3, close to negative pi. Okay, I get it. We get this little tangent curve inverse flip-flop like that. So I can pick a couple coordinates in the original to find the inverse graph, right? If we would have done the AP notes or the flip math notes, guys, they would have been more on the graphing. And I'm like, we didn't really want to go that route. We just wanted to do the brass tacks of what do you need to know? And this is what you need to know. When I'm dealing with inverse sine standalone questions, the answers can only be from negative pi over 2 to pi over 2, or else you're what? Gone. Okay, and that's why I gave you that thing in the beginning. By the way, you can mark this for later. So is its brother or sister. Same restrictions because they have the same quadrants where they're positive and negative. Same thing with cosine. Secant will follow the same real rules as cosine, right? And then I'll just color that in blue because they do have different restrictions. It's because of how the graph is different. It really is. All right. And then tangent, oh, go ahead and do this and get mad about it. Get mad. Inverse cotan, cross it off. It's a jerk. It's because we haven't talked about the graphing of cotan yet, which is a little different than we did last year because we're following AP like robots. All right. But cotan does not have the same rules as tan, and it kind of stinks. All right. So cross that off, and then we'll worry about that later. Okay. So how does this affect you in your life? Well, first thing is those struggling on the unit circle. We know this is 0. We know this is pi over 6. We know this is pi over 4. And we know this is pi over 3. No time to write the quadrants. Pi over 2. So cosine, I could be answering in quadrant 2 because cosine you're supposed to answer from 0 to pi. So we should remember that this is 2 pi over 3. This is 3 pi over 4, short of 4 pi over 4. This is 5 pi over 6, short of 6 pi over 6. But then here's really the key. This is why I did that one in the quiz is. Whenever you're naming a quadrant 4 angle, it's got to be in the negative. Gotta be. It's because why? It's not me, guys. It's the whoever powers of B that made this decision. It's really because of the graph, though. I don't want to blame someone for it. When you're naming a quadrant 4 answer with inverse trig question standalone, you must name them as negative angle measures. That's the what. The why, if you didn't understand anything I covered before, it does make me sad, but it's not really that important. Okay, so here we go. Now it's time. Do you know your unit circle? What kind of angle measure as a cosine? You get root 3 over 2 as a ratio. What's the angle? Is it an over 6 or an over 3? It's your only two choices. It's an over 6. By the way, whenever you're a positive ratio, you're always in quadrant 1. So I can't even ask you, what's the quadrant 1 over 6? It's just pi over 6. Got it? So let's go to another positive here. Where's another positive? 2, 3, 4, 5, 6. Which one? 4. 4 is going to be a quadrant 1. Sine of what kind of angle measure gives me 1/2 as a ratio? Over 6 again. This is why your homework's going to take 10 seconds a question. It should take less. Now we got problems. Everything else is negative. Okay, what kind of angle measure gives me root 2 over 2 for sine? Over 4. Okay, what's the restriction? Where's sine negative? It's quadrants 3 and 4, but I got rules. So what's the over 4 I have to list there? Is it 7 pi over 4 or is it negative pi over 4? What's the answer? See, that's the thing. Highlight this. If you write 7 pi over 4, what happens to you? You're gone. Why? The restrictions. Why the restrictions? 20 minutes of notes that I showed you. That's the only thing I gave you. That's all I can do for you. All right. This is out there, and this is what happens. All right. I don't have to do 1 over 1. What kind of tan of what angle measures gives me 1? 4s. Okay. Now, tan has the same restrictions as sine. So that's nice. Not 7 pi over 4 or you're gone. This is the what. Know the what more so than the why. All right. And then what kind of angle measures has root 2 over 2 for cosine? 4s again. Now, careful. Oh, and by the way, I forgot to do this up here. Never, when you're doing inverse sine questions, does quadrant 3 ever result. Ever. Notice that. You will never have a quadrant 3 answer angle when you're doing inverse questions standalone. So we know what kind of angle measure is it? Over 3, 4, or 2, or 6. Sorry. 4 is bad on my part. Okay, now it's the quadrant 2, 1. That was the restriction for cosine. Because cosine's positive 1 and negative and 2. Never 3. We never do 3. What is that answer? What's the quadrant 2, 1? 3 pi over 4. That one you do directly as a positive. You cannot say 5 pi over 4. All right, not allowed. And then arctan of negative root 3 over 3, which one is that? Over 3 or over 6? You got to get that down. And then 4, this actually makes your life easier. You don't even have to think about, is it 5 pi over 3, or is it 11 pi over 6, or is it 7 pi over 6? No, it's just flat out negative pi over 6. It's directly in the quadrant 4. Got it? That's the what. One more thing on this. I'll end with this, and I have my calculator already done. But you could do these, and I just want you to remember that your calculator has no ability to give you angle measures with pi in it. It will only give you a decimal. And I want you to remember that video that I showed you where the guy defined a radian, where you had this radius, and then it came off of there, that length, and then it imprinted itself on the circle itself. And then that was a definition of 1 radian, 2 radians, 3 radians, 4, 5, 6, and then we talked about 2 pi. Remember that? So this is 0 radians. This as a decimal is 1.57 radians. Again, I'm not going to be a teacher where I don't show you the why, and I hope you get a firmer understanding of things. And then here is wrong. I cannot name that 4 point or whatever it is. I think it was 4.71. This is negative 1.57 whenever you're dealing with quadrant 4 answers, because the calculator is built with these restrictions. I'll prove it. Go to your calculator and do number 9. The restriction for number 9 when you have a negative ratio is quadrant 4. So first of all, you have to make sure your calculator is in radians. Mine is. Second, quit. And then you inverse tan that negative root 5 over 2. Close the root. Negative 0.84. This is, my fat head's in the way. All right. Close this, I guess, for good, because we're done with cat for the day. Actually, I did not have to do that. I could have just hit this. So that answer should make sense because, pen again, negative 0.84 graphs this way in quadrant 4. Negative 0.8, right? Does that make sense? So I want you to make sense out of your calculator answers. Your answers for 7 and 8 would be between 0 and 1.57 because they're quadrant 1 answers. And you can type those and press enter. Got it? Okay, so we're going to continue on this tomorrow. Be a lot smoother because I don't have to worry about the why, but I can't be a teacher not telling you the why and just telling you, hey, there's these restrictions. Follow the restrictions. And I hope some appreciate that.